Hi, today we are going to be seeing Sentaurus TCAD, scripting on the Sentaurus TCAD, and specifically on SDE. There is an alternative way to do the same through the interactive mode, by wherein you can actually physically draw the lines and all, but this is a more impactful and faster way to do the same. So when you open the script, this is a sample script which for a project which has already been done. This statement define a variable name and the value attached to it. This is akin to assigning a value to a variable in C or any other programming language, for instance. So similarly, these statements overall assign numerical values to these variables, which can be used multiple times later on in the code. Then we come to this statement. Here, this T tot is equated to the sum of T poly, this one, T geox, which one, T sub, this one, and T box. So the syntax for summing multiple variables is the operand comes first, followed by operator comes first, followed by the operands. So plus followed by all the variables, 1, T poly, T geox, T sub, and T box, right? And that is equated to T tot. Understood? Again, these statements equate the length variables to a numerical value, which is 0.2. Another important thing I forgot to mention is all these are in micrometers. All the suppose if you write 0.2, it means 0.2 micrometer. Similarly, 0.1 micrometer. So all measurements have the common micrometer standard. Similarly, we again see L tot is summation of the operator comes first, followed by the 3 operands. Understood? So these are your basic variable definitions. Now we move on to creating figures in your of your device. Creating the regions of your device. So here, so for the basic statement for that is SDE followed by create rectangle. Here it's a rectangle because that is what we want. There are many other variants also that you can refer to the manual. So now let's take this blue box, this blue rectangle box. So to define the rectangle, all we need to do is specify two opposite coordinates, diagonal coordinates. So two diagonal coordinates will specify a rectangle. No other rectangle can be drawn if you mention two opposite ends of a diagonal. So that is what is done even in the code. What is the code? So here also that is what is done. There is position 0, 0, 0 and the position L sub. Okay, so L sub, T sub, and 0. So what the three numbers following the title word, that is the syntax word, position, are the coordinates x, y, and z, right? So here for this rectangle shape, we are taking the origin point. We are defining an origin 0, 0, 0 and a length term the distance along the x-axis L sub, distance along the y-axis T sub, and since we are not concerned about the depth term, we could keep it as 0. But it can be for a 3D device, for instance, that can also be utilized. So these two points define your rectangle. All right. Then this is the material you want the rectangle to be filled by. So we want a silicon layer there, and thus we say silicon. For example, in another rectangle, same create rectangle, we see SiO2 here, which means for this rectangular figure, SiO2 needs to be filled. Similarly, there are other polysilicon, etc., can be filled. This is followed by a name for that particular region. So I was named it as region substrate. The next one is region source. Next one is drain, so on and so forth. So so before starting starting to write your code, it is always advisable to draw. It is always advisable to draw this figure on your notebook. Draw a figure on your notebook and then mark the coordinates and then begin. So that will immediately give you the coordinates to be mentioned in the figure, and then you can proceed without any confusion also, right?